we were on the route reflector. Okay.
Yeah, correct.
We were talking about the route reflector, that what is route reflector and why we use route reflector. Okay. So theoretically we covered about the these terms. So I hope you guys have little bit knowledge about the route reflector. Okay. So
Yes.
might probably, can anybody let me know why we use route reflector?
Am I audible?
You are.
Okay. Like we use route reflector basically when we have an IBGP full mesh kind of environment. So
When we don't have full mesh, one thing. Okay. So
how
to
bad spoke about?
avoid the full mesh, we use route reflector. So when we have a large environment running with BGP end to end, either we can have full mesh, either we can have route reflector.
Router. Either one-to-one connected to each and every router or a route reflector client.
And why that is the reason? Reason is, if one IBGP peer getting a route, this route will be delivered to another IBGP peer, but this IBGP peer will not transfer this route to third one. So route from one will come to the two, from two it will not go to the third. That is the main logic.
One IPVGP peer not forwarding to another IPVGP peer.
That's true. That's true. And that is the reason either you need to have the peership with everyone. Okay. So that is known as full mesh. Everyone should be peer with everyone. Okay. That is thing known as full mesh. Else, what you can do, you can use ARA.
Hello.
Any doubt in this?
No.
Okay. Give me a minute. Let me just go for the topology. I am making the topology on because it will take some time to boot up. Meanwhile, we are discussing about it. We can just take the console. Okay. Let it get booted. So that is the route reflector. Now I have prepared a lab for you guys, okay, in which I will be having router 1, router 3, router 4, router 5, and maybe some router 6. Okay, and bit like they are like that. Now try to understand when we have such a topology. So R6, whatever the route on R6, might probably 6.6.6.6. These route will be going to the R5. And since R5 has their local routes, and these EBGP routes, whatever it is containing from EBGP routes, will be sent to R1. R1 will have all the routes which is from the R5 and from the R6. But these routes will not be forwarded at all to another IBGP peer. So on R3, on R4, on R5, there, sorry, not on R5 because we are talking about the R5 routes only. So these routes will not be going to R3 and R4. Is this part clear? And the reason why, because if you are talking about that this is your IBGP, this is all your maybe AS100, you can say AS100. So this AS100 is the IBGP peers, and this is your EBGP peer. Let us say this is 606 peer. Okay. So in that scenario, all the routes which we are getting from the BGP can be forwarded to the IBGP. Their local routes can be forwarded to the IBGP. But when this IBGP peer need to send those routes to R3 or R4, there is no capability to send those routes directly to these guys. And the resolution is either you can make the full peership. You just make the peership with R4 also. R4 will have these routes. You make the peership with R5 also. R5 will also R3 and R5 if there is neighborship. You can have those routes now on the R3 also. There is no hustle and bustle. There is no issues. But if that is not the scenario, there is no full neighborship, then what you need to do is you need to create RR. So what we will be doing, again, our topology, if we will see, this is our IBGP domain, AS, same AS 100 probably. This is some of the AS, probably 606 maybe. Now, if there is a connectivity like that we are connecting through the R1. So this is R1, this is R3, R4, R5, R6. If such a connectivity is there, all the routes which are going to till R1, okay? Now you can talk about if R3 is sending some routes to R1, these routes will not be sent to R4. These routes again will not be sent to the R5 as well. So this is vice versa. It does not mean that only I am talking with respect to R5, but it is the same case with the R3 and with the R4 also. Getting this point, guys? So far, any doubt, any question to anyone? So the possibility could be we can create R5 as route reflector client, or maybe R3 also route reflector client, or maybe R4 also route reflector client. If we are creating route reflector client on R1, R1 will be acting as the server. Now, whatever route reflector client is sending any update to the server can forward it to some another client. Even server can forward it to the non-client also. If I'm not creating it as a client, this route will be forwarded to R4 as well. I will be proving all of these fundamentals through our lab also, but you please try to understand what I am saying. And apart from it, last time I talked about that this particularly concept was introduced to avoid loops in IBGP. Currently, the loop can occur, but loop will not occur because of there are two attributes we are adding at this time when we are using RR kind of thing. And what are those two attributes? Can anybody let me know?
Originator.
Originating, yep, ID. Then, so one is the originator ID.
And community.
Second is
Cluster.
the cluster ID.
Okay.
So I would be talking about these two also. I would be showing about these two things also. Okay. And RR, when we are talking about RR, try to understand this RR setup, very minute, points. Not everybody will be clearing about these things. So this RR is known as inline RR. Reason being, the control plane is R1 and the data plane is also R1. All the data from R3, there is no other wire. So it will be going through the R1 to the R4. But let us suppose if we have some of the reachability like that. Okay. There is no BGP running in between R3 and R4. There is no BGP. But OSPF connectivity is there. Or maybe some IGP connectivity is there. In that case, there is no use that we should be sending the route through R1. The route can go directly from R3 to R4 like that. Okay. And such scenario is your R1 is not inline RR. It is only taking off the control plane. But the data plane can be go through your R3 to R4 directly. Try to understand this very minutely, very important, concepts. So in that case, you need not to require maybe R1 should install all the routes of the BGP routes in the routing table. Not required. Why it should be having the all the routes into its routing table? What we can do, how we can avoid that situation, I would be talking about all of that things later on, but I am just trying to tell you that what can be happened. Okay, getting this point? So this is not your inline error. This is your only for the control plane. Then let me tweak this topology little bit some more. So currently we was having like that. It was R1, it was R3, it was R2, it was R3, R4, R5, R6. Let me add one more router, R2, into the picture. And for R2, I will be creating a second, maybe, server that let us has, some more connectivity. Ideally, we should not use a single error. It is a single point of failure. So we can use one more error. That is not an issue. So in this case, from R2 to R5, route reflector client, R2 to R4, route reflector client, R2 to R3, route reflector client configuration would be done. Similarly on R1. But my question from you guys, is there any requirement or something like that, that there should be connectivity between two errors?
If one RR goes down, then somebody has to take over the responsibility. Right?
That doesn't matter. Try to understand the concept very minutely. Routes from R6, I am just focusing from R6, coming to R5, from R5 going to R2, from R5 going to R1. Let us say if R2 fails. So this route, if R2 is not sending to R3, R1 can send it, R4 can send it. How does it matter? Getting my point?
Yeah.
Why we require this link? Or ideally, this link should be there or no? If yes, why? If no, why? So this question, please keep pending for time being. I would be telling about this question later on. I will be coming to this question later on. But so far, are you guys getting the point, like what in this topology we would be doing? Okay.
Yeah.
So let's not wait for much time. Let us do these kind of practicals directly on the lab. So I created one lab for you guys. This is our lab setup. Okay, the same setup on which we were talking, I am just on the same setup as well. Okay, now if I will see the iOS. So one thing, these are the VIOS files, very hard to tackle with. So much time it will take to boot up. So if you want these files, I can give you these files if you need to prepare in your home. Okay. So let me just go with.
I was about to put in the WhatsApp group. Like I was trying the lab for this one. GTSM you said, right, in OSP. TTL security, all interfaces. On the normal GNS3 I was trying, I was not able to enter the command. So I was, then I recollected in PNet we did that discussed.
Right. So a couple of the commands are not, working on your normal iOS. So I used to take help from, these buddies.
Okay. Yeah. Just let me know when can we have that VIOS points. I will just import it.
Whenever you want, I can send. Okay, I can send by today. Don't worry.
Okay. Okay. I will try that.
Sure. I would be sending you today. So
yeah, please.
let's see here. Show run.
Yes.
Section router BGP. Now try to understand what I am doing. So R6 and R5 has the eBGP connectivity. Okay. So in the BGP, I don't running something very fancy. I am just running BGP 600 over here. And post that, I am running couple of the commands. That is network ID 666 I am publishing. The same network ID what it is having in between 5 and 6 I am publishing. And I am giving a remote command that it is AS100 point to point, nothing hanky fanky. show IP protocol. There should not be any other protocol. Okay, it should be only BGP. So you can see only BGP is there. Show IP BGP summary. If I will run, the network between 5 and 6 should be up, and it is yes. So you can see it is up and running fine from past 10 minutes. It's all right. So for this particular body 6, I don't think so that there is some issue, right? Now let us understand one thing. R1, R2, R5, R4, R3 are from the same AS, and that AS is AS 100. And since they are from same AS, the connectivity, if the connectivity part, if I need to go through, okay, because this is same AS, one thing what I can do is I can run some of the IP protocol, that is IGP for my loopback connectivity, only for those loopback which I need to create BGP on. If there is not, I can run these things on point-to-point network also. So let me see, let me check what I am doing into my network. So if I will go on R5, if I will go on my R5, you can see I am creating some neighborship. Okay, I have the neighborship with 2. I am saying next of self. I have some neighborship with 1. I am giving next of self. Okay, and neighborship with 6 also. So let me show you on R5 what I am doing. Maybe you can also do understand. R5, I have 2, 3 connectivity. One connectivity with 1, one connectivity with 2, one connectivity with 6. Okay. Over the 6, what we are using? We are using eBGP. Since eBGP is there, so no issue for the next hop self. But when I am sending this route to my IBGP peer, I need to add next hop self command. Otherwise, the next hop IP would be something from my eBGP peer. So that is the reason when I am sending these commands, when I am making the peership in between R1 and R2, I am sending 2 more commands, that is next hop self. Yes. Let me show you again over the R5. So you can see 1 next hop self, 2 next hop self, same IBGP peer because it is also 100, they are also 100, and 6 no requirement of next hop self because it is eBGP. Then probably I am publishing all of the networks which are included into my BGP table. Show IP protocol. I'm just checking, am I working with some another protocol or no? So you can see there is plain BGP just to show you end-to-end connectivity. Okay. Yep. So this is your R5. Now let us talk about. Okay, where is my? Let us go to the R4 and R3. Again, plain configuration should be there. Let us quickly check for R3. Show IP BGP summary. You can see R3 should be having 2 peership, one with RR1, one with RR2. Okay, so there are 2 neighborship which I can see with respect to your R1 and R2. Similarly, if I will check show IP protocol, there should not be show IP protocol. There should not be any other protocol except BGP, which I am running. If I will show you the BGP command, very plain command, it should be show run section running BGP. It is plain neighborship. And similarly, the case is goes with your R4 also. So let me show you the R3. Same, we are going with R4 also. So you can see nothing hanky-fanky, only the neighborship and the network command, nothing else. Okay. Now, main story comes for our RR. And which are our RR? RR are our R1 and R2. Okay. So let me see if I have all of the configuration. Let me remove those configuration first. Okay, I do have something. Conti no router BGP header. Let me just remove, everything. Okay. And just for the sake of backup, let me copy this and go to the notepad. Just run those commands which I don't want to, run again and again. So I'm going to the router BGP, assigning the router ID because I wanted to show you something regarding to your read. Okay. Then going for two, maybe for the time being, I can say no. Okay. 2 I don't want, 3 I did, 4 I will did, 5 I will did. Now let me show you again. Do show run section router BGP. Very plain configuration. Okay. So it is VIOS, takes some times to load any of the thing. Wait for a while. Exit. Control C.
It is not coming.
I am not coming. So run section router BGP. So you can see there is nothing hanky panky. We are using very simple command. If I will check show IP interface brief, I do have some of the interfaces. Okay. And even the read which I am using, that is not existing on my router, but it does not matter. If I want to publish this network, I can publish this network. Let me publish this network. Okay. That will not harm because I am not using any of the protocols. So network should be published. So let me just publish this network. Okay. Very quickly. 13, 14, 12 left, right? So let me publish the 12 as well. Right. Let me check again. Show.
Yeah.
Show run.
Run.
Section router BGP. Okay. So you can see nothing new. Okay. I didn't perform any of the action so far. So there is no new configuration. Similarly on R2, let me remove every configuration. So run section router BGP. And we will be configuring it all together. I would be showing you first what is the problem that is coming, then I would be resolving that problem. Okay. So let me just copy them and paste, and then go to the code T, and I need to say no BGP, removing everything else. Now one by one, just putting out the configuration. Okay. Now going router BGP, going for manual BGP ID. Okay. Then with 3 putting the neighbor, with 4 putting the neighbor, and with 5 putting the neighbor. Then let us add some kind of networks also. Networks. Let me check quickly. Show IP interface brief. I have 4 networks. Show run section router BGP.
Yeah.
Okay. So let me go in the conti router BGP 100, maybe one more network I can add, that is 12.
Yeah.
Not required, but I can add. It is not harmful. So let me do that. Okay. So end to end, let this BGP come up. Okay, end to end. Now we need to see the problem. So problem should be the routes which is coming from R3 over R1 should not be going to the R4, should not be going to the R5, should not be going to the R2 also. Similarly, the routes which are going from R3 to R2 should not be going to the R4, should not be going to R5, should not be going even R1. Okay, so that is our problem. That is our main problem that we need to seek out. So for the timing, just think about that we don't have R2 in the picture. We have the topology only one connected with this, and this is connected with your further router. So this is our topology for the timing. So we need to focus on that the R6 route should be coming to the R5, R5 route should be going to the R1, but R1 should not be sending it to the R3 and R4. Let us just validate it very quickly and going on R5. On R5, my neighborship should be up first for both of the peers. Show IP, BGP, show IP, BGP summary. And you can see I have the peership with 1, 2, and 6. 2 don't consider currently for to the picture. So we have 1 and 6 maybe. So if I will check show IP BGP, route 666 should be over here, and I can see 666 is there, which is coming from 600. That is your eBGP. So one validation from R6 route is coming to R5 or no? Yes, it is coming from R5. It should be going to the R1. Let us quickly go on R1 and check the same thing. Did I am receiving this route 666 or no? It should be there, and you can check. Yes, it is there. Even the route from R5 and R6, both routes coming to me. So I am just focusing on the routes which are coming from R5 and R6. So you can, one thing is clear to you guys, that whenever there is IBGP peer, this is IBGP domain. Okay, so whatever routes which are coming from here, it will be forwarded to your R1. So you can see 555 routes, that is also coming. You can see 666 routes, that is also coming. Any doubt so far?
No.
Now, since this is your IBGP domain, route forwarded from one IBGP peer should not be forwarded to R3, should not be forwarded to R4. Let us quickly check these things also. On R3 and R4, we should not be having 5 routes or 6 routes at all. So I am going on R3. Let me check show IP BGP summary. The peership with 1 and 2 should be up, but we are considering about 1. Show IP BGP, if I will check. Am I receiving any 5 route? No. Am I receiving any 6 route? No. And this is the problem. That is isolated. Similarly, the case with your R4 also. If I will go over R4, show IP BGP, you cannot able to find out any route from 5 and 6. Is the problem clear to you guys? Yes or no?
Yeah. Yeah.
Now the regulation what I told is the RR. And RR, if you will see into this picture, even though I can create RR client as this. Now the thing is, RR client is sending the update. It will be sent to the non-RR client. It can be sent to the non-RR client. And any update which are coming from the non-RR client will be absolutely sent to the RR client. So even if I will make my R5 as RRC, route reflector client, the problem can be resolved into this particular, lab. But better if we can create R3 and R4 also as a RR client. But let me show you first RR1. So I am going to the router 1, going to the config terminal, and this RR configuration you need to do into your BGP. And what I am doing is I'm just copying that configuration, and instead of 3, maybe I'm just using 5. Oh, it should be 15.5. Just one comment. I just said that 5, you are my router reflector client. By this way, R1 becomes our server and 5 become router reflector client. And this will resolve every problem which we were checking earlier. Let me show you on 3 R3 now. 3. Show IP BGP. And you would be able to see the routes from 5 and 6 are now reaching. Are you getting this point? Yes or no?
Yeah. Yes.
But the routes from R4 is not coming yet. So let us understand the picture again. When I am creating this as RRC, this is my router reflector client only. Any update coming to the server will be sent to the R4, will be sent to the R3. That is right. Any update from R3, from R4 will be sent to our R5 router reflector client, right? But when non-reflector client will send this, it will not be sent to the another non-reflector client. So the R3 and R4 will not be able to exchange their route in between. The problem what we were experiencing earlier also. So we need to create R3 or R4 also as a RRC. I'm creating all of them as RRC. Okay. Getting this point, guys? Yes or no?
In short, the non-reflector client will not send route to the existing route reflector client.
No. Please. Can you repeat again?
The non-reflector client, which is R4, is not sending route to R3, which is the which is the current route reflector client.
Non-reflector client send this route to
R1.
R1 will not send it to the R3.
That is true. That's right. Non-reflector client will not send to existing route reflector client.
See, it does not understand the RR thing come in between these two guys. Rest people are as it is.
Okay.
When this information will go to the R1, R1 understands that this is my router reflector client. I need to send it. The mirroring. So route from R4 will go to the R5. Instead, will go to the R6 also, but it will not go to the R3 at all.
Okay.
Got this point?
Yeah.
Very important and very minute to understand. So I hope you have the understanding. Now let me go to the R1. Last time we run it for R5. Let me run for the R4 also. 4.4 or maybe 3.3 also. 4.4 and now 3.3. I created the route reflector client. Every router is the route reflector client for the R1. Now, if you see now, any route which is coming from R3 should be go to the R4, should be going to the R5, from R4 going to the R3, going to the R5, from R5 going everywhere. So every route should be going everywhere. That is the thing now. Okay. So is there any doubt?
No.
Let me show you now. On R3, we should be having now 4.4.4 also, which we earlier missing. So you can see I have 3 routes, which is my local route. Then I am receiving 4 route from 4. That is IBGP peer, 5 route, 6 route. Every route I am receiving. If there is no doubt, maybe we can just see a couple of the more properties. Show IP BGP. 4.4.4.4. And here you go. Try to understand now. Okay, the thing what I was discussing earlier. It said, who is the originator? R4 is the originator. Originator ID is inserted in, and in the cluster list, what it is sending? The read of the router, who is the server.
Yeah.
Who is the server? And same information you can see that it is getting by 14.4. Okay, and sent by whom? Your this is a read, and this is your physical IP. This is also your physical IP.
Yeah.
Any doubt you have, please ask me.
That's fine.
It's fine?
Yeah.
Good. Now, if this is fine, let me just tweak out one parameter on R1. On R1, I can manually give some kind of cluster ID also. Let us say I am going to the config terminal, okay, and just running out these commands that my BGP cluster ID is 1. So if I'm doing like that, and I will go on R3 again and check the same information, are you able to see some difference? So in the cluster ID, you can see the cluster ID, whatever I created on my R1 is showing, even though it is showing in the 4-octet. Okay, earlier it was using the read. Now it is using the cluster ID. So cluster ID, if I am putting 1, it is showing into the 4-octet that, okay, it is 1. Whereas rest of the information like this, these informations unchanged. Just wanted to show you that you can put your cluster ID if you want.
This is used only for significance. Who is it?
Sorry?
This is used only for significance, if at all. But it is optional, right?
Yeah, perfectly. It is, but obvious option. I am just showing you the customization.
Yeah.
Okay.
Yeah.
So if it is not the problem, let me go to the R2 and set up everything on R2 also. Right?
Yeah.
Okay. Let me go to the R2 now. Oh, 24.4. Same configuration I am doing with respect to R2 also. Okay. Maybe if you want, I can go to the change the cluster ID also.
Yeah.
Okay. Now let us go to the R3 and see if we have some difference. Okay. Now IP BGP. Okay. So we can observe the R5 routes or maybe R4 whatever are now received by from two sides. One is from 2, one is from 1. You can check it through the IP.
Mm.
So router 2 is also sending, router 1 is also sending now. And again, if I will check the same command, you can check the originator ID and the cluster ID and everything with respect to these two guys. And can you see now the difference? Originator ID 444. Here should be the same. Cluster ID, this is sent by 2. This is sent by 1.
Still,
What is the local? What physical IP? 1424. Who is sending to me the physical IP? 23.2, 13.1. What is the read? This is the read. Originator would be same in the both case.
yeah, correct. And still R1 is considered as the best one.
Whatever is considered as the best path, that we will check later on. But I hope you will be able to see what I wanted to show you for the originator
Yes.
ID, cluster list, and
Yes,
everything.
yes.
And the same information, if I will check on R1 or maybe on R2, I can see that what are the routes which I'm getting from the route reflector client. Show IP, BGP, summary. I am receiving some, I should be receiving a couple of the routes from R3, R4, and R5. If I will check show IP, BGP, the 3 route is 33331, I hope. If I will check 1, can you see it received from a
RR.
And since it is aware that this route is coming from a RR client, this route can be sent to another RR client, and this route can be sent to the non-RR client also. How it will come to know that it is coming from my RR client or no? By that way. Okay, since this information is carried out in the routes that it is received from my RR client, that is the reason R1 can send it to another clients. Any doubt?
No, it's fine.
Fine. Okay. Now things goes for, as I was saying, if your RR is inline RR, it means you need to have the next hop for any of the route should be your RR only. Next hop should not be your some another ID. It should be your RR only in any case. So in that case, you have some commands which you can run. Let me show you. But before that, currently, what is the next hop? Let me check quickly. Show IP BGP 4.4.4.4. It seems it is RR only. Yes, it is RR only. But let us check again. Yeah, it is RR. Show IP route also you can see. So if you see, the best one is here you go. So what is the next hop? 14.4.
4.
Why it is that? Let us understand the topology again. There is R1, there is R4, there is R3. We are on R3, and the next hop, what we are observing currently is this 14.4. Whereas for R3, next hop should be R1. But there can be a link between R3 and R4, might probably, if 14.4 is the next hop, and we have the IGP, and this is the best for IGP maybe, this link can be followed up. But since this is inline RR, my data should be going to the R1 in any case. So what I can do is over R1, I can run one more command. Config T, router BGP 100, neighbor, what is this neighbor? 13.3, next hop self, and if I will put question mark, you can see there is a keyword named as all, which means that it is for IBGP and for EBGP both. And this keyword comes after the iOS 15. That is the reason I am using viOS. When I am putting this clear IBGP star soft, and if I will go to the R3 again, clear IPBGP star soft, show IP route. Are you able to observe the difference?
Yeah.
And why? Because R1 is my inline RR.
Whatever routes you want to reach out to me first.
But obvious, because
Yes.
it is not only control plane, it is data plane also.
Data plane also.
But let us say if this RR is not your inline RR, maybe. Okay, one more, or maybe on R2, let me show you. I can see show IP BGP. Under the BGP table, 3 route is coming to me, 4 route is coming to me, 5 route is coming to me, 6 route is coming to me, and under show IP route, everything is coming to me. 3 I am installing, 4 I am installing, 5 I am installing, 6 I am installing. Let us suppose R2 is not inline RR. Okay, this is only used for the control plane. R2, R3, R5, R6. Let us say there is a directly connectivity in between them, but it is not BGP. So since it is not BGP, R2 should be sending it as an RRC. All the control plane option should be coming to the R2. But when it is coming to the data plane, it should go directly because you have the route reachability, you should go directly. That thing we understood. But if anything is coming to the control plane, why R2 should be inserted it into its rib? Because it is not in line. None of the data traffic is coming to it. Why it should be installing its into its routing table? For that, we can be doing something else. Let me show you guys. Maybe for the route, we have the 5 route also, 6 route also into our routing table. I am going to the config terminal, access list, one. Should I do it as permit? Okay, let me do is permit. And we have 5555, 5555, 255, 255, 255, 255. This is a route. Let me go with the route map. Maybe any route map. I am just using ABC, denying 10, match IP address 1. Okay, and then I need to permit maybe my another statement.
Yes.
Permit 20.
Exit.
Okay, now this is done. Okay, what I could do is I could go into the router BGP 100, and here there is something known as table map. Table map, and if you will check, it is saying write down the word is ABC. Then what you want to do with it? I want to filter some selective routes. Okay, see here. Clear IP BGP star soft. Maybe it will not help with clear IP BGP star soft. I need to add some maybe another command BGP IPv4 unicast table map. Okay. Show IP BGP. If I will check, all the routes should be there as it is. Yes, 4 route is there, 5 is there, 6 is there. Show IP route. If I will check, oh, what happened? Why it removed everything? Show route map. I am denying it. Formatting anything else. Denying
Oh.
access list one. Show
What is
access list. Oh, it match everything. Access list is wrong somewhere. Yeah. Access list. 10 permit any. Why? IP. Okay. Access list 1 permit 5555 255 Oh, I'm sorry. I'm using separate mask. What happened? I need to remove first this.
remove it and press. Yeah.
This. So IP access list now seems good. Clear. BGP IPv4 unicast
Unicast.
table map. Show IP route. Here you go. So you can see the file route is not there now. The rest of all the routes are available into our routing table. This is something known as selective route download. And we need to achieve this using table. Any doubt?
This is nothing but a filtering only, right? Another way of filtering.
We are not putting it into our routing table, not filtering through the BGP table. If you will observe minutely, you can see the route is into the BGP table as it is. We are not filtering it from the BGP table, because if we will be filtering it through the BGP table, how this control plane connection will be going through them? It will break at all. But since we need not to be into our routing table, it's not a inline RR. So why to use full our routing table? Just leave it. So into our routing table, if you will see, show IP route for your 55555, we are not putting it there.
Okay.
Is this part clear, guys?
Yeah.
No question, right?
No. After in adjacency, the filter is applied and then BGP. Yeah, correct.
Okay. Now, question is something what I asked. Let me open that. I have shown you, all of the scenarios related to the RR. These two guys are RR. Then we have R3, we have R4, we have R5, we have R6. And we see that this is your eBGP peer. In turn, there is a connectivity with your RR like that. There is a connectivity with your RR bit like that. My question was, is there a direct link is required or no? Answer is yes. And if you will ask from me why, there can be n number of things which may be occurs, or there can be n number of a failover scenario which can occur, and due to what we can have we should have all the there should be a link between R1 and R2. And if you will ask how, let us say there is a link failure between R1 and R3, and there is a link failure between R5 and R2. Now, whatever the links that whatever the routes which are going from R5 will not go into this direction, it will go to the R1 only. And since there is a link failure between R1 and R3, these routes cannot be go to the R3.
Yeah.
In that case, if there is a direct link over here, these routes can maybe go from here to here. Just to keep every failover keeping into the mind, there should be a link in between your RR. Very important thing. Okay, and that is the reason why we created a link between R1 and R2. And when you are creating a link in between them, it's not required if you want to put it as an RRC that you can do, or maybe you can avoid that. Okay, because every routes which are coming from RR can be forwarded to your non-RR client also.
Yeah.
Any question?
Not so far.
Perfect. Let us then take a very quick break of 5 minutes, 5 to 7. Then we will be doing couple of more things into the BGP, and today BGP will be over. Then I am just closing this lab. If you don't have any question, if you have, please ask me, otherwise I am shutting it up.
Not so far, but I want to take a snapshot of this.
You can take the snapshot, that is not an issue. Even you can take the snapshot from the videos also, right?
Yes.
Okay.
Yeah, that's fine.
You have all the videos available, you can take the snapshot from there. Sure, buddies.